Here is a solid that has been created in PowerSHAPE 8 and needs to be updated to 2010. This solid has a history tree and we want to preserve it. The first stage is to convert the model into PowerSolid. At this stage, PowerSHAPE is rerunning the entire feature history tree of the part and converting all of the features one by one to PowerSolid. Because of the difference in the way that PowerSolid handles some of the solid modeling operations, some of those solid features may fail to redefine. You'll receive a warning that tells you which features redefined and which did not. In this case, there is a general problem with the solid, and that is probably the base solid that was used for the die wizard initially. There is also a fillet failure. Open the history tree and locate the fillet that failed to redefine. Double-click on it to open the edit page. You will find it easier to see which fillet it is if you go into wireframe view. The failed feature will be highlighted in yellow. In this case, the failure is caused simply by the fact that PowerSolid has merged the surrounding faces. So the number of faces that PowerSolid is trying to fillet is actually different. But in this case, the track is okay and we can simply accept it. Otherwise, you can choose a new fillet or use the more advanced options if you wish to create a variable radius instead. Saying OK at this stage reinstates that fillet and all is well. But there are now some problems with the main solid. We could run the solid doctor at this stage and repair the solid, but that would almost inevitably lose the feature history tree. Instead, locate the feature, the secondary solid, and use the copy solid command. This extracts the big lump solid and we can now edit that on its own. Run the solid doctor on the new solid, and here we have an edge fault and also a large hole. The hole is the outer edge of the part, so we can ignore that. So select the hole and say ignore intentional hole. From the master node, select the bad edge and say repair. And now recheck. You will sometimes find that extra faults seem to have appeared. This is simply because of the way that PowerSolid does its checking. As soon as it finds a serious fault, it will stop. Select the edge faults and automatically repair them. The remaining fault is a trimming problem. Select the fault and extract the surfaces. As before, blank the original solid. At this point, the two surfaces come together to form an almost infinitely thin neck. PowerSolid rejects a surface that looks like this. Instead, PowerSolid wants to have two separate surfaces. Select the surface, copy it, and paste it. So now there are two identical surfaces. Select either surface and open the Trim Region Edit toolbar. Select all of the boundaries on the surface and explode them. You can now recreate the trim boundary for this surface. So that is the first surface corrected. Now pick the second surface and repeat the procedure, but obviously this time collect the other side. So now two surfaces remain where there was only one before. As always, select the surfaces and sew them back into the main solid, which you can now recheck. Because we marked the outer edge as a deliberate hole, that solid is now perfect. All that remains now is to bring back our original solid, making sure that it is active. Open its history tree, locate the fault that we just fixed, and in this occasion say replace solid, pick the solid that we have just repaired, and perform the Boolean operation again. And now our solid is repaired, but has retained its full history tree.